In an electrochemical cell, reaction of lead at a standard temperature, if this is E naught value of lead 2 plus changing to lead, reduction potential of lead 2 plus is m volt, reduction potential of this will be lead 4 plus is n volt, and the value of E naught from lead 4 plus is given by m minus nx. The value of x is, write the stepwise reduction of lead, that is lead from plus 4 oxidation state changing to plus 2 oxidation state, and from plus 2 to lead. This is stepwise, and one is the direct conversion of lead from plus 4 to lead. Lead from plus 4 to plus 2, E naught value, let it be E naught 1. This you have to find out. Number of electrons involved in this step is 2. Lead from plus 2 to lead. This is given in the question as, the E naught value is given as m volts, let it be equal to E naught 2. Number of electrons involved in this step is also 2. Lead from plus 2 changing to lead in 0 oxidation state. So total electrons accepted in this step is 2 electrons. Next is lead from plus 4 oxidation state directly changing into lead to 0 oxidation state. Here the number of electrons involved will be 4, and let the E naught value of this step be E naught. Now for step 1, let this be step 1, this is step 2, this is step 2, and this is step 3. So for step 1, delta G value, delta G naught 1. For step 2, delta G value is delta G naught 2. And for step 3, delta G value is delta G naught. Number of electrons involved in step 1, N1 is equal to 2 electrons, as lead changes from plus 4 to plus 2 oxidation state. So decrease in oxidation state is by 2, so it accepts 2 electrons. For step 2, number of electrons involved is N2, which is equal to 2 electrons. Here lead changes from plus 2 oxidation state to 0 oxidation state. For step 3, the number of electrons involved is 4, as lead changes from plus 4 oxidation state to 0 oxidation state, so it accepts 4 electrons. Now writing the expression, delta G naught is equal to delta G naught 1 plus delta G naught 2. The delta G naught value for lead from plus 4 oxidation state changing to lead, that is for step 3, will be sum of the delta G values of the step 1 and 2. Putting the value of delta G naught, it is equal to minus NF E naught is equal to minus N1F E naught 1 plus minus N2F E naught 2. Simplifying this equation, this becomes, now this can be written as minus NF E naught is equal to minus N1F E naught 1 minus N2F E naught 2. F gets cancelled, and taking the minus sign in common, this becomes minus N E naught is equal to minus N1 E naught 1 plus N2 E naught 2, minus minus cancels. Now putting the values, value of N is 4 into E naught value for the third step is given as N volts. So 4 into N is equal to value of N1. N1 is equal to 2 into E naught 1, that you have to find out, plus N2 is given as M, E naught 2 plus N2 is given as 2 multiplied by E naught 2, which is M. Rearranging, now taking 2 as common, 2, this is E naught 1 plus M. So 2 2s are 4. So 2N is equal to E naught 1 plus M. So E naught 1 is equal to 2N minus M. Now E01 is the value of EMF when lead in +4 oxidation state is changing into lead in +2 oxidation state. So E01 is equal to 2N minus M. Therefore, for the reverse reaction, that is lead in +2 oxidation state, lead in +2 oxidation state changing into lead in +4 oxidation state. This will be equal to the reverse, that is E0 value will be equal to minus 2N minus M, that is M minus 2N. This is from +2 to +4. So in the question the value is given as M minus N into X. So here the value of X will be 2. Value of X is